This is DSMA 11. In this section, we will talk about line graphs and slope. Let's take a look at this image. Sometimes in a mountainous region, you may see a symbol such as the road sign that we are looking at with the truck and the 25%. The 25% is referring to the slope or the incline or grade of the road, which is quite important for those truck drivers that have full loads or perhaps an empty truck to safely maneuver down the roadway. And it would be important for us to know also so that we can give ourselves some distance between those type of trucks that are on this grade. This next image shows us two different types of slopes. The first one is a positive slope. A positive slope rises from left to right when we're looking at that line. When a line is decreasing from left to right, it is considered a negative slope. The definition of slope is the slant or steepness of a line. Let's take a look at this image. This image gives us a line with 2 points on it. The first point here is in parentheses x1 comma y1, and the second point, parentheses, x2 and y2, close parentheses. All right, so notice that this line is slanted or tilted, so it does have a slope. In order to show the vertical movement, we have what's called a rise, and we take the second y minus the first y to find the rise. To find the run, we take the second x minus the first x coordinate. So this gives us a formula to find the slope of a line given 2 points. So I'll write out slope, and we use lowercase m to indicate slope, and it is the second y minus the first y divided by the second x minus the first x. Once again, this is the slope of a line. For this problem, they want us to plot -4, 6 located at the x on the graph. So let's take a look at the graph and do some labeling on it. First, in the middle here where that black solid dot is, this is called your origin. The ordered pair that represents the origin is x is 0, y is 0. Notice over here we have what's called the x-axis. And above we have going vertically is the y-axis. So the x-axis goes side to side, left to right, and the y-axis goes up and down. To plot a point, we want to start right at the origin where that black solid dot is. And we're going to look at our ordered pair, -4, 6. Once again, remember that the -4 represents the x-coordinate, the 6 represents the y-coordinate. So we're going to take the x is -4, and since x is negative, we're going to move to the left from the origin, 4 units to the left. All right, and then we're going to move vertically up. Since 6 is positive, we're moving in a positive direction, going up 6 units until we reach our destination. We'll put a solid dot here, right where that red X is, and that is -4, 6. All right, so when we take a look at what we call a rectangular coordinate system and divide this out, we have our x-axis and our y-axis. We have 2 and 3 and 4 quadrants on here. So let's take a look at that. That's quadrant number 1, quadrant number 2, quadrant number 3, and quadrant number 4. All right, the sign for our x and y coordinates in each quadrant looks like this. So x is positive and y is positive in the first quadrant. All right, in the second quadrant, x is negative, y is positive. Third quadrant, x is negative, y is negative. And in the fourth quadrant, x is positive, y is negative. For this problem, we are going to find the x and y coordinate for point C. Now, in order to find the x and y coordinates, remember we have to start at the origin. And with the origin, we start with the x value first. We either move left or we move right. Left is negative, right is positive. Lastly, we'll move to our y-coordinate, which is either up, positive, or down, negative. So starting at the origin, I'm going to count how many places I'm moving here. 1, 2, 3, 4, and this is, my x is 5. So I had to move 5 units to the right. And then I'm going to move 1, 2, 3, 4 units up. So that is y is 4. So x is 5, comma, 4 for y, and that is our coordinates. And it says type an ordered pair, so make sure on my math lab you are typing in 5, comma, 4 with parentheses. For this problem, although there are a lot of points on here, in particular, it's asking for the x and y coordinates for point G. So let's focus on point G. Once again, we're going to start at the origin. We're going to move towards G, move right or left first, then up or down. So once again, starting at the origin, I'm moving to the right, and I'm stopping at x is 5. And then I'm going to move vertically down. And I need to count how many places I've moved down. Now remember, moving down is a negative direction. Moving up would have been positive, or moving down, it is negative. So point G has 5, negative 5 for its coordinates. Once again, you want to write this down with a negative sign and include those parentheses. Make it look like that ordered pair. So let's try a different one. Let's try point E as an echo. Again, we're going to start at the origin. We're going to go towards E, which is to the left 4 units. And going to the left is a negative direction, so negative 4. And then I'm moving down 2 units to that point. Down means negative 2, right? Moving in a downward direction makes it a negative number. So the ordered pair for E is negative 4, negative 2. For this next problem, it's asking us to graph the equation y is equal to 4x plus 4. Now, there's a few ways that we can graph. One of the first ways we're going to show you is how to do what's called a t-chart. And you basically randomly pick numbers for x and find what the corresponding y value is. So for instance, I'm going to make what's called a t-chart, and I'll show my work here. So I like 0 because multiplying by 0 is rather easy. So I'll say, what if x is 0? Now I'm going to replace that 0 into the original equation where it says y is equal to 4 times my 0 plus 4. Well, 4 times 0 is 0, and that's going to give me y equals 4. So that means my coordinate is going to be 0, comma 4. Right, and we'll just substitute in another value for x. We can put in 1. All right, so y is equal to 4 times 1 plus 4. And 4 times 1 is 4. 4 plus 4 is going to give me 8. So I have 1, 8. And I like to try maybe a negative number. So let's do a negative 1 and see what happens. So in this case here, I have y is equal to 4 times negative 1 plus 4. 4 times negative 1 is negative 4. Negative 4 plus 4 is going to give me 0. Remember, we're creating ordered pairs here. So for instance, this is 0, comma 4, 1, comma 8, negative 1, comma 0. All right, and then we can place our ordered pairs or points on the graph. Remember, we only need 2 points. So when you look at something like this on my math lab, it may ask you to find 3 points. When it comes to graphing, you just want to choose 2 of those points. So we'll go plot the first point, 0, 4. Again, we start at the origin. we move 0 movements left or right because it's x is 0 and y is 4. So I'll place a little dot right here. Actually, this graph is so little, I might make it a big dot because I have a feeling I'm going to draw you a nice crooked line. And the next one is 1, 8. So I need to move over 1 unit and go up to 8. This is 1, 8 right here. Then I have -1, 0. And that looks somewhere right here. And if we wanted to, we can keep doing more points. So what happens is you go in and you graph this and you place a line that goes through this. And before I draw my line, what I want to do is show you another way to graph this. This next way uses what's called the slope-intercept form. And it is where you take y and solve for it. So y equals mx plus b. And we know what that m is. That m is my slope. And the b is the y-intercept, or where your graph touches or crosses the y-axis. So in this case here, we can grab our equation, which is already in slope-intercept form, y equals 4x plus 4. Right? My slope is 4, so I'm going to say m is 4, and I'm going to make it look like a fraction. The reason why I'm doing the fraction is so we can do rise run. And if you remember, if the number is positive, like this 4 is positive, we're going to move up 4 units. The 1 is positive, that refers to my x values. We're going to run to the right. You can also go the opposite direction from this. We could have gone down 4 units and to the left 1 unit, and we'll still get the same slope. Remember, that's the slant or the steepness of a line. And then we're going to take a look at this 4 over here. Remember, this is 0, 4. This is my y-intercept, which we already have on our graph. At 0, 4, this is the very first point that we placed. All right, and from the points, what you can do is you can graph your y-intercept. This is the green dot I just placed on the graph. And you rise up 4 units. That'll take you to 8 and move over 1. All right, and then we can rise up 4 again. That'll take us to 12 and then move over. And we can keep doing this little stair step action and get more points. You can also go the opposite direction. You can start back at that y-intercept, and we're at 4, 0, 4. So if we go down 4 units, we're at the origin, and we go 1 unit to the left. All right, and we go down 4 again, we're at -4, and move over to -2 for x. Again, you can go -4, units down, 4, and to the left, 1 unit. So again, if you keep stair-stepping this, you will have your line. Now, this is where we get a little messy on drawing, but that's okay. You have the idea. So we're going to draw our line that goes through our coordinate system with arrows on the tail end. That line never ends. All right, this is the point where I say I may draw a crooked line, but I'm not crooked in life, and that's an important fact. All right, so this is our first exercise on graphing. All right, for this one that says find 3 ordered pair solutions by completing the table. So when they're saying ordered pair solutions, solutions are actually points that will create a true statement on your original equation. In other words, we can check them, and we'll do a quick check on one of these so you can see. Our equation here is x minus y is equal to 6, and looking at the table, they want us to complete the table. Now, the first ordered pair, they gave me a y, and they're indicating that I need to find the x value. So let's write down the original equation. I have x minus y is equal to 6. All right, so the first one, they're going to look for x. We're going to substitute in that 0 for y, and this will give me x is equal to 6. All right, so the ordered pair here is going to be x is 6, y is 0. Right, then I'll take a look at the second ordered pair, and they give us x is 2, and they want us to find y. Put a little line right here, and I'll say x is 2 minus y is equal to 6. So we're going to solve for y. And what I will do first is I'm actually going to add y to the right-hand side of my equation. All right, and that will give me 2 is equal to 6 plus y. And then I'm going to subtract 6. Now you can work it in a different fashion. We should get the same answer. We're dealing with the same equation. All right, so 2 minus 6 will give us a negative 4 for y. All right, and the last ordered pair is looking for x, given that y is negative 3. So I have x minus, be careful with this one. There's a minus sign, and we insert for y, which is a negative 3, is equal to 6. All right, so we have x minus a negative 3. So we're going to do a little rewrite there. That minus a negative 3 makes it a positive 3. And then I will subtract 3 from both sides so I can solve for x. And x is equal to 3. All right, so we have a few different ordered pairs going on here. So we have 2 negative 4 on that second ordered pair. And the last one was 3 negative 3. All right, so it says complete the table below, which is what we did. And it says then use any two of the ordered pairs to graph the equation. All right, so we're going to pick the first two and see how that works for us. So we're going to go graph 6, 0. Again, we start at the origin. We move 6 units to the right in the positive direction for x, and we do not move up or down because y is 0. Place my point. All right, you only have one point that represents an ordered pair. Next ordered pair is 2, negative 4. So again, we start at the origin. We go 2 units to the right, so I'm at x is 2. And then y is negative 4. I need to move down 4 units and place my dot. All right, and from this perspective, I have my 2 points, and I can draw my line. And we are done graphing this problem. So again, it wanted us to complete the table, select 2 points, plot them on your graph, and draw your line. All right, so I said I was going to come back to this idea of a solution. All right, and what I meant by checking, I'll just do a check on the very first ordered pair that we created. So that was 6, 0. The question could be, is 6, 0 a solution of your equation? So what we do is we take our original equation, x minus y is equal to 6, and we substitute in our values for x. So we have x is 6 minus y is 0, and then there's a question mark right here. Does the left side equal the right side? And if it does, it checks out, and then this 6, 0 is called a solution. Solution of the equation. The line graph shows the number of students per teacher in public elementary and secondary schools for the years 1998 through 2006. Approximate the number of students per teacher in 2001. And it does say on here for us to round to the nearest tenth as needed. So this is just an estimate. So when you first take a look at our graph here, we have to find the year 2001. And 2001 will be embedded in between 2000 and 2002. Just insert it right there. And what we do is we find our year 2001 and we look vertically up till we get to our point that's on the graph. And now we're going to move straight to the left, trying to buy a little dashed line here, not too well here. There we go. And so we're looking at what would be the y value if you had to estimate on here. So in this case here, I would say this is really close to about 16 decimal point 2, only because I know that it is, here's halfway. This would be 16.5, and it's about midway between 16 and 16.5. So a good estimate would be 16.2 or 16.3. This problem reads, the number of students per teacher in public elementary and secondary schools for the years 1998 through 2006. Between what years shown did the greatest decrease in number of students per teacher occur? So we're looking for the greatest decrease. On the decrease, you're looking for a negative slope, and you want to look for, all of this is actually a negative slope, but you want to look for the one that has the sharpest decrease. And it looks like it is occurring right about in this area here. And that would be between 2004 and 2005. That is what I would type in on my math lab, 2004 to 2005. All right, speaking of slopes, let's take a visit on some of the slopes. There are 4 types of slopes. We already went over the rising from left to right. This is a positive slope. This is a decreasing or a negative slope, decreases from left to right. If you have a horizontal line, our slope is equal to 0. And if you have a vertical line, our slope is undefined. All right, so these are the types of slopes we have. And right now we're working with positive and negative slopes. Find the slope of the line. Y is equal to 4x plus 2. All right, so if you take a look at this and we're looking for slope, you should recall what we've seen earlier in my slope-intercept form. We can identify that an equation has been solved for y, so y is equal to everything else, then the number in front of it is the slope. The equation that we have is already solved for y, so the number in front is my slope. So slope is equal to 4. So we would choose answer A and type in the number 4. Again, we are asked to find the slope of the line. In this case here, if we take a closer look at this problem, 3x plus y is equal to 7, what we will notice is that we have to do some maneuvering to get y by itself. Remember, we want a positive y equals to everything else. So I need to go in and move my 3x over to the right-hand side of my equation. I do this by subtracting. If positive 3x, we subtract 3x. What I do to one side of my equation, I need to do to the opposite side. So 3x minus 3x will cancel out, and that leaves me just y on the left-hand side minus 3x with a positive 7. Once again, I'm trying to put it into slope-intercept form, y equals mx plus b. Now that I have y isolated, I can look at that number that's in front of x, and that would be my slope. So the slope of this line, we would choose answer A, and we would put negative 3. So we have another problem asking us to find the slope of the line. In this case here, we have 6x minus 7y is equal to 42. We are going to solve for y. And in doing so, that places it into slope-intercept form. So the first thing I want to do is leave my y term right where it's at and move my 6x to the opposite side by subtracting it. All right, and then that leaves me with a negative 7y is equal to negative 6x plus 42. I do not quite have my y by itself, so what I need to do is to undo this multiplication. This is a negative 7 times y. I will divide, but I have to divide every term by negative 7. That's called an equation. We need to keep that equal sign. So negative 7 divided by negative 7 is 1. And 1 times y is just going to leave me a y on that left-hand side. A negative 6 divided by negative 7, a negative divided by negative gives me a positive. And positive 42 divided by a negative 7 leaves me negative 6. So once again, the number in front of x is your slope. So slope is 6 over 7. We'll choose answer A and place 6/7. Notice it does say to simplify your answer. So if you get a fraction, you always want to look at your numbers to see if you can reduce any further. All right, giving you a little refresher back on this slope. If we had to look at this graph of this line, y is equal to 6 over 7, x minus 6. That's in slope-intercept form. My slope is 6 over 7. 6 is positive, so that means I would rise up 6 units. 7 is also positive. That means I will run to the right 7 units. This minus 6 is going to be my y-intercept. If x is 0, I'll get negative 6 for y. So the first thing we want to do if we wanted to graph this is to go ahead and graph the y-intercept first, 0, negative 6. And next we would rise up 6 units and move to the right 7. Let me see if I can get that drawn in here for you. All right, so if I were at 0, negative 6, somewhere about so, and if I rise up 6 units, I'll be at the origin, move to the right 7, and we'll put my dot right here. And so if I had to graph my line, it would look something like this. Again, this is 0, negative 6. We went up 6 units and to the right 7. Rise over run. For this problem, it's asking us to use the slope-intercept form to graph the equation of the line. So they gave us y is equal to 8/3 x minus 3. You want to identify that this is in slope-intercept form, so it's giving us our slope of 8/3. And once again, the y value on the top is positive, so it means I am moving up 8 units. The denominator 3 is positive, it means I move to the right. Another way that I could write this slope also is to say that it is a negative 8 over negative 3. And I'm demonstrating this just to show you that you can go in the opposite direction also. So since the numerator is a negative 8, this means you would go down 8 units. And the denominator is negative 3, so we would go to the left. So it is exactly in the opposite direction as the original slope, but it will still give you the same slope of the line. The next thing we want to identify is our y-intercept. The y-intercept, x will always be 0. If we put 0 in for x, we will get negative 3, which is the y-coordinate or the y-intercept. All right, so let's plot this point. So we're going to plot 0, -3 on our graph. Start at the origin, go down 3 units. And then from 0, -3, we're going to go up 8 units and over to the right 3. All right, so that's giving us, it looks like 3 and 5 for that ordered pair, 3, 5. And then we'll draw our line. All right, so once again, we plotted our y-intercept. We moved up 8 units, and then we moved to the right 3. Our final problem is once again asking us to use slope-intercept form to graph the equation. Our equation is y is equal to 2x minus 3. We can confirm that this is in slope-intercept form. So with that information, we are able to look at the value in front of x, which is our slope. And we'll say slope is 2. And since we have to do the rise run, we're going to take 2 and rewrite it as a fraction. So we'll put 2 over 1. Again, 2 is positive, so it makes our movement vertical going up. And the number 1 is positive. We move to the right. So up 2 units, to the right 1 unit. Next, we're going to grab our y-intercept. This is where we touch across the y-axis. X is 0. We need to go find y. And y is going to be -3. Once again, that is your y-coordinate for your y-intercept. So we'll go plot this y-intercept first. 0, -3. Start at the origin, go down 3 units. And then we're going to do rise run, and we'll just do a few of these. It says that we just need to put in 2 points on a graph, but in this case, I'm going to do a few more. So we're going to rise up 2 units and move over to the right 1, place a little dot, rise up 2 and to the right 1. And it's a nice little stair step action. Keep rising over and moving over 1. And you can see that we have a line. And if I wanted to, I go the opposite direction from that y-intercept. I'm up back at 0, -3, go down 2 units to the left 1. Down 2 to the left 1. So if we plot enough on here, you should see that we have a line. And this confirms that we have a positive slope, which 2 is positive, and my line is tilted the right way, so I know we're doing okay. And again, if you just have a nice natural number, place it over 1 and do rise run from your y-intercept.